we are looking at water properties, and that is on the fourth property, the property related to water's density. So we are saying that water has got a highest density at 4 degrees Celsius, meaning that above 4 degrees and below 4 degrees, the density of water is small. You can think of it like this is peculiar, this is just strange. The densest portion of water is at 4 degrees Celsius. 5 degrees is lighter than 4 degrees. 3 degrees is lighter than 4 degrees. Can you imagine that? So if you want to show, just to make it look much sensible, if this is 4 degrees, when you get to heat water, the temperature is going to be increasing. So this side is showing density. Okay. This will be density. And then this is temperature here. As you are heating water, the density is increasing. When you reach 4 degrees, that is the maximum. If you continue increasing the temperature, the density is going to drop. So the density of water is highest at 4 degrees. Well, if you go above 4 degrees and below 4 degrees, water is much lighter. Now, when you talk of solid water and liquid water, I'll just remind you of what we did at grade 12. Solid, liquid, and gas. Which one has got particles more closely packed? From what you can remember. Where are particles more closely packed and densest? Okay. From what we know, solids have got particles more closely packed. And then liquids, at least particles are less closely packed. And then in gases, they are sparsely packed. When it comes to water, this is not true. Actually, for water, these two swap themselves. For water, liquid water, the particles are more closely packed and the density is higher. And so water, the particles are sparsely packed and then the density is smaller. That explains ice floats on water. That is because the density for ice is smaller than the density for liquid water. So we are going to find that the water that is at 4 degrees Celsius is at the very bottom of the river. And then you have got 3 degrees Celsius, you have got 2 degrees Celsius, 1 degree Celsius, and then 0 degrees, that is ice. So ice is at the very highest of the water. And this is important because if you talk of John, fish does not die even if there is ice on top of the water. Why? Because the fish are going to go at the very bottom of the river and be swimming there. Why? Because at the very bottom of the river is so it is not possible to fish in June. If they ask why is it not possible to fish in June in biology, that is because fish goes at the very bottom of the river, and for you to go deeper down the river it will be very difficult. Why have they gone to the deepest of the river? Because it is very cold on, and the cold water is supposed to be on top. So when you talk of water itself, the densest or the particles are more closer in liquid than in solid. From what you already, it is just opposite of what you know. So when you talk of solid here and liquid, remember we're talking about hydrogen bonds. Actually, liquid water has got about, okay, first we'll start with a solid. Since it has got particles which are fixed shape, in a solid, each water molecule about 4 other water molecules. In other words, there are about 4 hydrogen bonds in a solid. But because water flows like liquid water flows over each other, that is why you see rivers flowing. They are just an average about 3.5, 3.8 hydrogen bonds in liquid water. We have not even said there are 3.8 hydrogen bonds, but average. I'm saying average because bonds are constantly breaking and forming, like water is moving over each other, the top of the other as water is moving. So there is just an average of about 3.5, 3.8 hydrogen bonds in liquid water. You can't say there is a 3.5 hydrogen bonds. No, it's average. Unless in solid molecule is bonded to four other water molecules. So one water molecule is going to be bonded to water molecules, so it is going to form four hydrogen bonds. So I've talked about the importance of water having its density like that. It's important for fish, like in cold seasons. That is why fish can be able to go at the very bottom of the river and be able to survive without dying. So that is the importance to the property of water related to its density. Talk of fish. Now, another property that you need to know is tension and surface tension. Now, the first question is what is cohesion? From where co means like more same. So cohesion tells us that each water molecule attracts another water molecule. So the attraction, the force that attracts molecules that are the same, that is what we call a cohesive force. For example, alcohol attracts alcohol, water attracts water. Maybe Christians attract Christians, drunkards attract drunkards. That is cohesion. So that's that attraction between similar molecules. Now, surface tension is just that force that is on the surface of water. The river. Remember, water has got hydrogen bonds. So the water which is at the surface going to be attracting each other very much. They are going to form a lot and stronger hydrogen bonds. So they more like hold there. The surface for water is more stable because of the hydrogen bonds which are found in water. And why those hydrogen bonds? That is because of cohesion. Each water molecule attracts another water molecule, which attracts another water molecule. We're going to form more like a thin layer. They form more like a thin layer on the surface. So because of this, it appears as if there is a plastic on water. If you watch Tom and Jerry, you find that if Tom drops on water, he will not sink. He will just be on top of the water before he can go inside. This explains why insects such as mosquitoes, they can walk on water. Insects can walk on water. Why? Because of this thin layer. There's a layer that arises due to the attraction of water molecules to each other. So that explains why insects can float on water. And another thing is if you get a glass, something like a glass, add put some water there, drop some water, and then get an as you put on top. You can't separate these two glasses. Why? Because water molecules get to attract themselves, just like attracts another surface. Now that's another property that I want to talk about. That is now called adhesion. So adhesion or adhesive forces, these are forces which attract different molecules. For example, water can be attracted to alcohol. Even at times, Christians can be attracted to non-Christians for maybe transformation's sake. And more when you're talking about adhesion, we're going to give an example of water and glass. You can try get a glass cup, which is of course made from silver oxide. I mean silicon oxide. If you get a glass cup, you add water there and then try to pour out the water. Not all the water is going to come out. There will be some water that will be left on the surface of the glass. That is adhesion. Water is going to be attracted to other surfaces. This explains why things wet. For example, when you drop water on a Chitenge material, it is going to get wet. Why? Because there's an interaction between different molecules like water and the surface of that material that you've dropped water on. And another thing that we can look at this, when you are in a lab, you get mercury and water, you add in a test tube. In one test tube, you are going to see that the water is going to be like, in another test tube, you are going to see this. So this is water. When you add water in a test tube, this is what you are going to see. but when you add mercury, this is what you are going to see. Now, what explains this? You can see there is a concave up of the meniscus. This tells you that there is a stronger attraction between the water, this is water inside, to the glass. So there is an attraction between water and glass, meaning the adhesive forces are greater than the cohesive forces. So the forces that attract in different things are greater than the forces that attract in the same molecules. But if the water molecules would rather attract themselves, or sorry for using water, that's the mercury would rather attract themselves. Attraction between the same compound is greater. So here cohesive forces are greater than adhesive forces. Why? Because the interaction between the mercury and the glass is not that much as compared to the interaction between the mercury and the, why there is this high level. So this is adhesion. Okay, that is adhesion. So adhesion is very important also when it comes to the vesicular system, for example, in the xylem vessel. It explains why water is able to move in the xylem. Now, the movement of water in the xylem, cohesion together with adhesion, and another thing that we're going to talk about. And now let's talk about it. That property of water, that is capillarity or capillary action. Okay. Now, when you're talking about capillarity, simply the ability of water to flow upward in a narrow vessel without the assistance of external forces, like in a vessel, without the existence of any force outside. Like things can't go against gravity. We know that you can, like something can't start going up, but water can be able to flow in a vessel going up against gravity without any force helping it. This is only due to the and the adhesion. So cohesion, one water molecule attract another water molecule. One water molecule attract another water molecule. And water molecules are going to be attracted to the surface of the vessel. That is maybe the xylem vessel or the phloem vessel. So that is why water is able to flow going up. So capillarity action is due to the action of cohesion and adhesion, which together causes water to work against gravity. And it occurs when forces of adhesion to the vessel walls are stronger than the forces of adhesion between the liquid molecules. So when there is a greater force of attraction between the vessel and the water, then that water is going to be able to flow going upwards. So this is very, very much important in the movement of water going up. And it is very important for the survival of a plant for water to be able to move. So capillarity is due to cohesion and adhesion. So this is about water and its properties. That is what we need to understand. Water and its properties. Knowing water and also the properties, what is the importance of each property that water has. And that is it.